Number 4.
F of x equals.
This is it. Wasn't this your sheet?
Yeah.
Okay, so remember I messed up a little bit on Friday, and oh, I see what you're talking about. Oh, my bad. Okay. Okay, let's go ahead and do this one then. This is for take 1. So we do have to, before we can find that H and that K, we need to take that number in front out. Okay, so this is going to be 3 times x plus, well, if I divide it by 3, what's left over here? 2 over 3, right? So where is my vertex for this one? Negative 2/3, 0. So whenever I graph this, so it's going to be, you can have a number here, but if you have a number here, you have to take it out of, factor it out, exactly. This is actually a minus. Sorry.
Wait, you can have a number outside the absolute.
Yes.
But you can't have a number.
You see it now?
You can't have a number with the x.
If you have a number with the x, you have to take it out in front, right?
And then the vertex is always that plus.
Yes, yes. So HK is your vertex. Opposite sign, same sign. You got to have it there. I mean, technically, you could pull it out and put it on the outside, so you could write it like this. But it's still got to be part of the equation. So here's what I would do. I would pick, and this is where I would definitely use my calculator, right? I know negative 2/3, 0, but I would definitely take out my calculator. And let's just make sure we can all go into that table there. Okay. Sorry, I'll wait on you. No, you're good. All right, y equals math under the green alpha button. Scroll over 1, see where it says NUM at the top, and ABS. Enter. And now I'm going to do my, what was the equation? 3x plus 2? 3x plus 2. I can do a zoom 6 and I can look at it. Zoom 6 and I can see what it looks like, but really I want that XY chart, right? That table of values. Remember how to get there? Second graph, right? And I want to go 2 points to the left of that vertex, and I want to go 2 points to the right of that vertex. So that vertex was at negative 2/3. So to the left of negative 2/3, maybe I want negative 1 and negative 2. Oops. Hold on. Negative 1 and negative 2. 1 and 4. You take your vertex and then pick 2 points to the left and then pick 2 points to the right. So now if I want to go in the other direction, 1 and 2 maybe. Those would be perfect. So maybe I want positive 1 and positive 2, and I get 5 and 8. Now all I have to do is graph these points, right? I'm not going to worry about being exact with this vertex. I'm going to say it's about right there, but my other points are going to help me. But that vertex is crucial, right? Because that's the point where it shifts and it turns. Negative 1, 1, negative 2, 4. You have some nice graph paper there that makes it a little easier to graph. And then, what did I mess up? 1, 5, and 2, 8. Yeah. Yeah, that's fine. It's more work on yourself, but you can do that. Yeah. No, you just need, because it's a line, it doesn't matter. So if you picked, you went 1 over it, so you like added 1 in it. Yeah, you don't have to do all that. Yeah. Well, so no, but the only reason I took the 3 out was to find the vertex, right? That gave me that vertex negative 2/3, 0. Once I have that, it's easier if I plug in numbers to plug in here than it is to plug in after I take it out. And you get the same thing. If I plug negative 1 in here, negative, watch this, negative 1 plus 2/3 is hit second window and change that independent to ask instead of auto. So here, Leah, this is absolute value of negative 1/3 is positive 1/3, and 3 times a third is 1. So you still get the same thing. It's still, I mean, we didn't change the value of the equation. We just rewrote it different. Ella, did that answer your question on that? Did it change it? Yes, the domain here would be negative infinity to infinity. What about the range, though? What'd you say? What'd you say? 0 to infinity. Inclusive or exclusive? Inclusive. Include it with a bracket. Yes, no, maybe so. Yeah. I thought we did 8. We didn't do 8. Did we do 7? Yep. All right, let's look at the first one. The first one we talked about extensively on Friday, and we talked about whether or not I needed the vertex, right? So look at it first and tell me if I'm just talking about this first one, where is the vertex on this one? Inside the absolute value would give you your x. Yeah. 0, negative 4. That's exactly right. 0, negative 4. Does everybody see why? There's no, so remember, there's no h inside, so it would be 0, and then the k is the number outside the absolute value. So 0, negative 4. So that's my vertex, right? Now the question is, and you can really look at it this way, is this less than or equal to negative 3? 0 is smaller than negative 3? No, right? So if I'm on my graph, 0, negative 4 is somewhere here, but this graph is getting cut off at negative 3 and only taking to the left. So that doesn't matter that it's there. It's not going to be included. So I really only need to plug in, negative 3. And when I plug in negative 3, what do I get back out? Two times negative 3 is negative 6. but it's absolute value. So it's positive 6 minus 4, which is 2. Open or closed? Closed. So negative 3, 2. Now I pick one that's smaller than negative 3. Give me one smaller than negative 3. Negative 4. If I plug in negative 4, what do I get back out? 4? Listen. So negative 4. There's that piece. Now remember, this is my vertex. If I graph the whole absolute value, it would look something like this. But I don't need any of that because that's the part I'm cutting off. That's not the piece I want. That's why I didn't need the vertex. All right, then I have y equals negative 5 between negative 3 and 2. So when x is negative 3, what's y? Y'all can do this. Negative 5. No matter what x is, y is always negative 5. So negative 3, negative 5. And then 2, what's y? Negative 5. No matter what, it's negative 5 because it's a horizontal line. Yes? Then the last one, same thing. I'm going to plug in 2, and I get what? 0. That's a closed dot. Then plug in an x that's bigger than 2, so maybe I pick 3. 3 minus 2 is 1. There's that. How about domain? There you go. Range is a little bit tougher, right? I've got this one value at the bottom, so I'm just going to put a negative 5 here to pick up just that one value. And then from 0 to infinity. Nope, they won't connect. Yes. That's saying stop and don't pick back up until you get to whatever this next piece is. The same number. That's when it's a parenthesis and not a bracket. Because this means include negative 5, but if I said this says don't include 2. Right. When it's the same number back to back like that, it's leaving out just that one number. Right. What else? Everybody good? Did you have one? Which one? 7? Number 7, another piecewise. Y'all love piecewise. Wait till you see your work today. Even more piecewise. Ah, clearly it's important, right? We've been camping out at piecewise for a while. SAT and ACT, as you get ready to take those, they love piecewise. We're going to do some inequalities with the absolute values. These are equations. Inequalities they're with the shading. And y'all have another project coming up this week too. That's a required one though. Yes. No, it's the drawing project, like the stitch up there and the ones on the board there. kind of tough before you get all excited about it. Those are all piecewise equations. the the ice cream cone's one. Which one? Oh, this week.
We do that next. We do that. Oh my gosh. Oh.
Like the Stitch one, yeah. Now she went above and beyond. Like she got like bonus and extra credit. That's Bella Walker.
Oh, Bella.
The Friends turkey right beside it. That's one. All the little pictures that are hanging on the chalkboard. You don't have to be able to. There. Look at Sullivan's, the birds, the angry birds going down right behind Trayvion's head. The 3 pieces of graph paper hooked together. And the butterfly beside it. Yeah, we're doing that this week. I'll tell you all about it. It's just you use different functions. I'm going to teach you about transformations first, and we'll do it. But it's all piecewise. They're all piecewise functions. All right, y'all ready? It's not going to be bad. I'm going to let you use Desmos and use.
I love Desmos. Honestly, Desmos.
Huh? There's some creativity bonus points available. Like when people turn in something like that Stitch or that Friends turkey, or like the girl, you see the girl with the black hair and the red headband? That's one too. Yeah. All right. All right, here we go. If I plug in 4, what do I get back out? It's funny because some of you are already thinking about what you're going to draw and you don't even know what the problem is going to be. No, you're not. All right, -2 to -7. This one doesn't have a vertex because it's just a linear. We do. So I'm going to do an open die. So then you said we could use 3. And it gives you -5. I love your attitude, though. All right. Now, here's where we have to think about this. Do I need the vertex, yay or nay? What is the vertex, first of all? 3, 0. Is 3 bigger than 4? No. So, in fact, if this is where I'm cutting off, here's my vertex. I don't need it, right? I don't have to worry about it. That's going to be my vertex for whatever else this is doing, but all this is cut off. So I don't have to include my vertex. So I just do this problem just like I did the problem before, and then I plug in 4, and I get what? 1. Whoa. 4, 1. And then 1 bigger than 4, so maybe 5, and I get those. What's your domain? How about the range? Close, but it's not a bracket. It's a parenthesis because that dot is open right there. Are we feeling a little better? All right, take just a second. Talk about how this is different with inequalities. So your homework, your classwork slash homework, because you'll have a lot of time today to do it in class as opposed to so much homework. So we may even call it classwork. We'll see how far we get. All right, so the difference now is we're also going to throw in some inequalities where it's not just y equals, it might be y is greater than or y is less than, and it's really not going to add a whole lot to it other than two main things. So for this, if you see greater than, if you see less than or greater than, what it's going to do is it's going to give me a dashed absolute value. And it would be dashed because it does not include the actual boundary. Okay? If it's less than or equal to or greater than or equal to, then it's going to be solid. And then, well, it's like a dashed line. And then the other part is shading. Okay, so if it is greater than or equal to, I'm going to shade up. In other words, like this, or on the outside of it if it's going down. Have y'all done things like this before? I feel like y'all should have graphed inequalities before.
It was like a whole line across the whole thing. It was linear. Right.
There you go. Shading down if it opens up looks like that, and shading down if it opens down is in the middle there. And that is really the only new thing about absolute value inequalities. You don't want me to do one with you?
Oh, yeah.
Okay. So this will be practice also on the absolute values, right? Because you have to be able to graph those. And then you also have several piecewise on here to do as well. Two piecewise. You have four just plain old. I think I ran it. Yeah. Gosh, I really wish I was going to be here Thursday. I have to do. I was really hoping it could be a project work day, but I don't know if I'll have enough information to you yet to do your project. We'll see. Could actually do two lessons today, but it's going to be short. But the other one's not short. We'll just let's see where we go with it. Let's see what happens. All right. What's the vertex here? Close. Why, Cody? That's exactly right. I got to take that 3 out first. Nice job. Remember, if there's a number hooked in front of x, I got to take it out first. Well, for this one, since the negative's outside, you don't have to worry about it. So if I wanted to put it, I could do this. Yes, yes. You can do it either way. I didn't get rid of the negative. This is inside the... Yes. You can. I could do this either way. Either one of these is fine. They both end up the same. That's just the y part of your vertex, right? You can plug into any of the 3 equations there you want to when you plug in. The only reason I'm manipulating it is so that I can find the vertex. That's the only reason I'm doing anything to it. Oh, yeah, the 4 is still there. It doesn't. I'm sorry. So my vertex is negative 3, 4, right? All right. So now I'm thinking about my table. It is sad. It's a sad one. What do you think makes it sad? The negative in front, right? All right, negative 3, 4, and now I can take out my calculator, or I can do it by hand, whichever way I choose. And I can pick 2 x's smaller and 2 x's bigger. So maybe, come on, negative 4, negative 5, and then bigger, maybe negative 2, negative 1. Okay, y'all need me to show you how to do this. All right, so no, what you're going to do is y equals, all right, the negative sign first, right? And then it go in y equals first. Negative and then math over to num, ABS, 3x plus 9. Close that parenthesis so it closes off that absolute value. And then plus 4. Yes.
Y equals negative.
Second graph, yeah.
Once I get the absolute, what do I do?
All right, so just make sure you close off this. Oh, hit enter. I'm sorry. Yeah. Yes. Now, second graph. Uh-oh. Did you put negative or did you put minus in front of your absolute? I think she did. Cool. All right, negative 3, then what did I say to put? So I picked 2 that were smaller, and then I picked 2 that were bigger.
Also, you don't need a positive. I thought you had to have a positive.
Oh no,
I
just.
had another error.
Are you doing minus or are you doing negative? negative 2, 1. And then negative 2. All right, so let's plot these. Yes. Right. So they're all technically open because I'm not including any of those. This is where things start getting a little meh. Okay, so I will generally just put a point and get all this on here and then just know that everything on this graph is not included. Okay, everything on the actual lines. Yes, that's fine for this as long as your line for your sides are dashed. Yeah. That's kind of the general. Yeah, right. Because dashing the entire line, this just kind of gives you a guide as to where your lines are going to be. So negative 2, 1, and then of course 1, negative 3. So now if I just kind of come in and I dash this whole thing, then I know that all these points on it are actually not included. They're actually kind of like open dots. Yes. It goes on forever. So now I have to determine which way I shade. So since this is a less than, where do you shade? Down in the V.
Okay, can you not work another one so like you do another one?
So don't do another one, you said?